When we think about artificial intelligence, we usually picture something abstract, right? Something that just exists in the digital ether. It feels kind of like magic. But today, we're going to pull back that curtain and look at the very real, very physical price tag that comes with all that magic. So let's just jump right in with a number that's, well, it's pretty wild. A single question you ask ChatGPT can use up to 10 times the electricity of a simple Google search. Yeah, 10 times. And that right there is just the very, very tip of a huge physical iceberg. So why that massive jump in energy? Well, it all starts to make sense once you get past this big idea we call the illusion of immateriality. We love to say AI lives in the cloud, but here's the thing. That cloud isn't some fluffy thing in the sky. It has a very real and very heavy physical address. The truth is, AI is built on this absolutely colossal physical foundation. I'm talking about these massive buildings, data centers, just packed to the rafters with powerful electronics. And every single chip, every server had to be built from metals dug out of the ground. They all eat up immense amounts of power just to run, and eventually they all become electronic waste. It's really anything but weightless. And when you have a foundation that big, well, it's got an equally huge appetite. This brings us to the first major cost on AI's environmental bill. Its absolutely insatiable hunger for energy and resources. Take a look at this. 552 metric tons. That is how much carbon dioxide got pumped into the atmosphere just to train a model you've definitely heard of, GPT-3. All that energy was spent just crunching trillions of pieces of data, tweaking billions of settings, over and over, until the model learned what it needed to. And get this, that's all before it ever answered a single one of your questions. Okay, 552 metric tons. What does that even mean in the real world? Well, let's picture it this way. It's the same carbon footprint as taking 123 regular cars and driving them nonstop for a whole year. And again, that was just for the training. And here's the kicker. This problem is getting bigger, and it's getting bigger fast. Projections show that by 2027, the energy needed just to power AI systems could account for 0.5% of all electricity used on the entire planet. Now, you might hear 0.5% and think, that's not so bad. But on a global scale, whoa, that is massive. We're talking about the entire AI industry potentially using the same amount of electricity as a whole country, like the Netherlands or Argentina, just to stay on. So yeah, this is not some small niche problem. This is a global energy challenge. So all that energy has to go somewhere, right? And it does. It turns into heat, an incredible amount of heat. So much, in fact, that dealing with it has sparked a whole new multi-billion-dollar industry. Think of it like AI having a really, really expensive fever. So, what do? You've got these specialized AI processors running hotter than anything we've ever built before. How do you keep them from literally melting down? The old way of doing things, just blowing air on them with fans, that just doesn't cut it anymore. Not even close. The answer, it turns out, is liquid cooling. And we are not talking about some tiny niche market here. Between 2024 and 2029, the market for these liquid cooling systems just for AI data centers is expected to grow by almost $1.9 billion. That's how huge the heat problem really is. So why the big switch? It really just comes down to physics. The special chips that power AI, it's like cramming a supercar engine into a tiny shoebox. They generate this incredible focused heat that air just can't move away fast enough. Liquid cooling isn't a luxury. It's the only thing keeping these billion-dollar systems from frying themselves. Okay, so we've covered the energy to run them and the money to cool them. But what happens at the end of the line? This brings us to the digital afterlife. What happens to all this incredibly powerful, super expensive hardware once it becomes obsolete? See, the thing about AI is that it moves at a blistering pace. A chip that's the absolute best of the best today could be basically a paperweight in just a couple of years. This crazy fast cycle of new and improved is creating a literal mountain of electronic waste. And this is what that mountain actually looks like. It's the physical graveyard for our digital dreams. Every single server, every GPU, every circuit board that powered our questions and our prompts ends up somewhere. And this is the stark reality of it. And the crazy thing about all this e-waste is that it's this weird paradox. It's a toxic treasure trove. On one hand, it's packed with valuable stuff we need, like gold, copper, and palladium. But on the other hand, it's also laced with dangerous toxins like lead and mercury that can cause serious damage if they're not handled the right way. So when you see all of this, you have to ask, what are we actually doing about it? And this is where we get to a really important moment of reckoning and responsibility. The good news is that policy and innovation are finally starting to catch up to the problem. One of the key ideas pushing for change is something called extended producer responsibility, or EPR. Basically, think of it like flipping the script. Instead of leaving you or your local government to figure out what to do with old electronics, EPR says the company that made the product is responsible for it for its entire life. It gives them a real reason to design things that last longer and are easier to recycle from the get-go. And it's not just top-down policy either. There's this amazing movement bubbling up from the ground called the right to repair. It's a direct challenge to the idea that our expensive gadgets are just designed to break. By demanding access to spare parts and repair manuals, this movement helps all of us use our electronics for longer, which means less waste. It's such a powerful idea, it's already becoming law in places like the EU and New York. So this leaves us with the fundamental question, doesn't it? AI is on this incredible path of getting more and more powerful. But as we race ahead, can we make sure our innovation and sustainability keeps up with our innovation in computing? Can we build a smarter future without wrecking our planet in the process? That right there is the challenge ahead of us.